Can I just put it here? Well, hello everyone. First, I would like to thank Cassidy and the Google Developer Group organizers for giving me currently part of. And I'll jump in straight into the presentation. So Erin is a very small startup. There are only 6 of us. We are based in Paris. The whole company started about 2 years ago and was founded by 2 ladies. Talk about them. But Erin is on a mission. So Erin is trying to use machine learning technology to accelerate mutual understanding in subject matter depth. So what it means, what I'll be talking about for the next segment. Subject matter experts. So first, these are founders, Linda Field and Felicia Davidson. So Linda is a serial entrepreneur with background in human acquisition. Felicia Davidson founded several companies to Linda to work on this exciting project. Linda's our CEO, Felicia is our what we'll talk about today. So we'll start with a sample Erin persona. We'll get into the methodology. We'll talk about product and architecture, and minutes, questions and answers. So you'll see that we are still a very early stage startup. We are only on seed funding. We are planning Series 3 sometime next year, maybe in a year. But we already have made extensive inroads to this problem that we're trying to solve. So what's the problem? Let me tell you a story. And as professional developers, you all have seen it. You all have been a part of it. You all see it. So Erin trying to make it. So meet Jim, our persona. He's a CIO of a large numbering enterprise, and he has to lead many, many complex projects. Projects at that level are complex. A lot of people, a lot of problems. Things are entangled. Complexity comes in different shapes and sizes. So things get become complicated. That's easy to sorry. Consisting of many connecting parts and layers. Or they be just complex, not easy to otherwise or understand. So what does Jim to do? Typical Jim's day consists of working with technical leadership to understand their expectations and spend money there. It has to deploy technical resources to solve it. But as a CEO, it also works with business leadership. These guys have agendas, business problems, a lot of people. Well, as a CEO, he also works with independent leadership. meaning people from other companies and other organizations. And these organizations could be vendors, could be OEMs, could be value-added resellers, the whole spectrum. The CEO is a public face of the company, has to deal with all this. How can ARIN help? So, typically, Jim will involve IT leadership to understand the expectations. He will deploy internally. Uh, Sometimes he will employ consultants for solving evaluators, OE. And Jim's problem. So he has to work with all these people, understand their needs, understand their agenda, plow through all of it, sort it out, and come up with a clear solution. And they are. Examples of these projects are vendor proposal. You're at a large company, you're trying to onboard and give them the typical setup is that the meeting goes for weeks. So you have a project manager, 3 or 4 expensive architects there. All they do is sit there and ask questions. Then project manager leaves, spreadsheet is done, so people have to come up with those questions. So what Jim has to do, he has to ask questions, he has to make phone calls, he has to communicate, he has to come up with metrics. So all of that, a lot of work, and a lot of expensive resources. Well, we all know it's complicated. All complicated. You know the complicated. In the process of this inquiry, Jim will discover dark data. Dark data meaning it's data that nobody even knew about, or they had a developer who left 2 months ago. Nobody knows what for you, but piece of work. Why? Nobody knows. To deal with dirty data, meaning that some of the questions and answers, some of the answers you will collect will be inaccurate, incomplete, or erroneous. People have agenda. They will push their things what they want, as opposed to what needs to be done to deliver product. And sometimes you have ready. What does ARIN propose? Very simple thing. It's been done before many different times. Just use rational reasoning process. Define a single simple component. We create questions. We let people answer questions in a collaborative way. We find clear correlations and patterns between the questions and answers. We help come up with better questions, better answers. So through this process of inquiry, the ARIN hopes to make this discovery and understanding requirements process easy. So what does ARIN do? It collects, processes, and shares inquiry. What's the outcome? Accelerate how human analysis and decision. As people answer questions, we build decision trees. So some questions lead to other questions. Other answers lead to more questions. Keeping track of this seriously, so people just use that. ARIN aims to change that and maintain these questions and answers so that people who have to deal with these complex issues can keep track what's happening, who answered what, when. This is how our current UI looks like. So currently web app, we are planning Android and iOS applications as our needs allow. And this is how this is an example of ARIN model library. So as people come up with these questions, so we package them as a library question. This is an example of a very simple listening function. So we keep an hierarchy. So hierarchies can go deep. So some if these questions lead to other questions. We let people use rocket drive nicely. Yeah. platform. And just a couple of words about architecture. So we are using global platform in Firebase. Both our front end and back end with Node.js, machine learning, full stack of code. We use both SQL and NoSQL. We use NoSQL for basically is our API entry point, and we use MySQL shipwriter coming with it. But our brains are TensorFlow. Believe it or not, that's it. Now that's TensorFlow. TensorFlow or not, that's the fine. And this plugins actually can work with the hardware and the Python maybe got next years. All right, so that's basically all I have. And again, Aaron is about questions. Yeah, just a side note, Aaron is hiring. So we're hiring a full developer. We're also hiring a machine learning developer. So if you know somebody or you know yourself to basically bring the new kind of AI into life, use up. Thank you.
All right. Can you guys hear me okay? No? Yeah? Thumbs up? Okay, good. Let me see. Well, I'm getting set up. I'm Matt. I work here at Nav. Sorry, set. And we're in. Okay. Awesome. Let's see. Cool, we're good. So anyway, I'm Matt. I work here at Nav. I've got a history of doing mobile development. I've been doing that for 12, I don't know, 13 years, something like that. I have been doing Android traditionally for most of that time, a little bit of iOS, but for the last year and a half, I've been doing Flutter. It's pretty awesome. So today, what I want to do is talk to you a little bit about Flutter architecture and how to build scalable apps for Flutter. So often we run into problems where you just go and you start building an application and you just dive in heads first, and then you realize all these problems that you have, and if you did it this other way, you'd avoid all those problems. Hopefully this will kind of demonstrate a little bit about how you can avoid those problems. But let me stop and say that, like, I hope this is really open. If you got questions, just stop me, ask them, like, be as candid as you'd like to be. There's mics if you want to use a mic, that'd be helpful. I'm happy to repeat your question, whatever works for you, but please just stop me and let's talk about it. If you don't understand anything, you have any questions, whatever, happy to walk through anything. So there's a demo app that I wrote for this that you're welcome to go on and dive into and look at, pull apart. You know, like I'm not going to do any pull requests, so because this is just a demo app. But what it is an application that illustrates the architecture that we use here at Nav. So at Nav, we're rebuilding our mobile applications for Android and iOS. There's 3 of us rebuilding these things, and we'll have a release date here, I think early September. And the applications have been rebuilt using Flutter. We are able to share close to 99.9% of our code between the 2 applications. Between themes and styles, everything looks and feels really good in the hands of both iOS and Android users, and it's been really good. We've developed it at an incredibly quick pace, and we're able to hopefully provide our users with a much better experience than we have in the past. The demo that I put up here is based on the architecture that we use here at NAV. It's been, I think, hopefully, I'm saying this because I did it, but I think it was well thought through. I hope it was, and it'll allow us to be able to scale. So we could pile on and put 15, 20 guys on this, or people on this, and we should be able to do just fine. And it should be able to scale really well for that. So the goal behind the architecture, we had several things that we wanted to accomplish. One was we really wanted to go really fast. The sample app provides, oh, let me go back in the sample app. The sample app provides some things out of the box. So you'll get theming, light and dark mode, functional API service. We'll talk about what that is in a minute. Some examples of providers and repositories. Again, we'll talk about that. A simple pattern of block and how that works with widgets. And block is really important, so we'll get into that in a minute. And then it handles various states the app can be in. It has support for environments. Inside the sample app, you've got a production and a development environment. That's typically used if you've got like different endpoints that you want to hit for when you're talking to your production server versus like a dev server or something like that. It supports localization out of the box, and it has dependency injection. Just a small example of how to do that. So it's got a lot of things. It only took a couple hours to build, but it's in the exact same kind of structure and format that we use here at NAV, and it's been very successful for us. So just got romantic in here, didn't it? Right. Okay, so some of the principles that we wanted to follow when we decided to re-architect was we really wanted to follow a single responsibility principle. This allows us to be able to write a class and have it be responsible for usually just one thing. That'll help us. Ultimately, the goal of this, right, the very high level goal, we want really maintainable and readable code so that if like somebody gets hit by a bus, somebody else can come in and they can take this and they can own it and run with it, and it's going to be really easy for them to read and maintain. It's one of those things. If you've written an app and you go away for 3 months on a Hawaii vacation and come back, you're just not going to know what in the heck you wrote 3 months ago. So we want to try and mitigate that as much as possible. So clean, maintainable code, really important for us. We want a really clear separation of concerns. What this will do as teams scale bigger and bigger is it'll allow us to be able to not even have to have a conversation about where something goes. So immediately, the other two guys that I work with are iOS devs. They can come in and they can say, hey, I need to build this feature. Here's the things that I need to build. We're good to go. I know where they go. I know where they belong. I know how they function. I know how they talk to each other. And it can be really clear. There's only 5 concepts that we deal with, and they're listed here in this kind of like funky little graph here. UI, blocks, repositories, providers, and API service. And we'll talk about those in detail. So the goal of the architecture, we want to be able to scale. We want it to be really testable. Every one of these layers is, we could pull out a layer and we could mock it out, and the whole app would still function. So it allows us to be really clean and separated. And these are principles that are well established, based on solid and clean principles. So if we go back and we look at like the first layer there, the API service, we're going to start inside and work our way out. Our API service, or the concept behind it, is that we have this thing. How many of you have done Android development before? Anybody? iOS development? Okay, like a HTTP client. In Android, we have something called OKHTTP. We use something similar here. It's called Dio. There's a few to choose from. And maybe I should go back and talk about Flutter, but if anybody has questions about Flutter before we get into this, let's talk about it. But the HTTP service, what it does is it allows us, or the API service allows us to be able to manage our headers, have interceptors so that we can intercept responses and requests and do things that we need to do there, maybe cache stuff or maybe inject headers at a certain time. Allows us to manage what our user agent is if we're talking to different people, set up different environments. Like I talked about earlier, we have like production, and the sample app has a production and a dev environment. You can add as many environments as you want. We use 4 in our app, so that's a scalable thing inside the sample app as well. And then like timeouts, like our request timeouts, and all of those kind of concepts, those really core things that allow you to communicate with the outside world, they're all managed by this one class called an API service. So you can call whatever you want, but that's what I call it, an API service. So one responsibility, right? It's to talk to the rest of the world and do that effectively and communicate in a good way. The only thing that can talk to that API service is this other thing called a provider. A provider is really simple. It's just it's a set of classes, or usually you're gonna have a set of classes. And let's say that I want to talk to Firebase, and I want to talk to my local storage on my device. They're two different places, so I'm going to create two different providers. One's going to talk to Firebase. One's going to talk to my shared preferences or my SQLite database or whatever. And then what I'm going to do is maybe the one that talks to Firebase is the one that talks to the API service. And the only thing that can talk to that API service is a provider. Does that make sense? So we have the API service. The only thing that it gets to communicate with are these providers. And these providers usually are in charge of things like our gets, our puts, our posts, our deletes, those types of things. So inside of there, you'll have basic functions that says get me a user, and it will return a blob of data back. And then you'll have like get me this like preference that the user checked, some checkbox, and give me that preference, and they're just really straight in and out. Yeah. That's going to be in the next layer, but yes, yeah. So these generally are going to be really specifically tied to some kind of data store. Their job is to fetch data, and that's it. Not to do any kind of logic, right? The only logic that might be in there is like I need to have like this URL for this like specific get or whatever call. So they're associated with just one data source, and that's about it. So at Nav, we have like several different services that we can talk to. And so we'll have a provider. One of them is called Allosource, and it does a bunch of stuff. And so we have one for there. Another one's called Bookie. So we have another provider that talks to Bookie. So we've got several of these providers. And what it ends up happening is they're reused. So we may have this service over here that goes and fetches like financial data for somebody. We might want to show that in several parts of our apps. And so that concept, that application or that class is going to get reused multiple places. So hopefully it's like we can write it once, it has a single purpose, but it's reusable. And so that makes it really great. We only have 3 people. We got to write a big old app. We can write this once. We know where the code belongs. It's really clearly defined, and we can reuse it in multiple places. Any other questions about providers before I move on? Skip a bunch of slides. This is a problem. What's going on? All right, we'll go in this. Okay, so we're going to go like little mode here. Sorry about that. Repositories are the only thing that can talk to. Oh, my graph's gone too. And this is an epic failure. See this little thing right here? That's the image. I don't know, maybe I dropped like a movie in there. I don't know. So repositories are a set of classes that only can talk to providers, and a repository may pull in more than one provider. So conceptually, we're thinking like, I need to load a user up, but my user ID that I need to load up, I store on the device. So a repository is going to do 2 things. Like I may have a function or repository that says like get user. First thing I'm going to do, I'm going to go to my shared preference, my local storage. I'm going to pull that user ID out. I'm going to take it, and I'm going to do the next thing. I'm going to talk to another different provider that's going to like go and do the get call to pull the user out, and then I'm going to be able to provide that data to the person that's calling me. So repositories usually and often will have like multiple providers inside of them. So you're going to have like multiple data sources that you're going to feed your data out to someone. So we're kind of like starting with like this little API service to these providers that talk to different sources of data, to these repositories that then reuse these providers all over the place. So we have like an auth provider, and that auth provider provides us the ability to, an auth repository. And in the auth repository, we've got our login and logout method. And so we can reuse that. Logout is used in a different place than login. But the goal of this, what it does is it lets us encapsulate our data and make it very secure and safe. So we're only exposing to the classes, like the UI classes that are going to use these, we're only exposing the things that need to be exposed. So we also, like an example of this is we have Stripe in our applications to do Google Pay and Apple Pay. And we don't want to expose like the Stripe key all the way up to our UI, because what if somebody accidentally put that in a text view or something like that? I mean, then people are just going to go and like go hog wild and spend all their money. So we want to limit that, right? We want to encapsulate that into these classes. And so our keys actually live in the API service as part of our environments. Our environments are those things that allow us to like switch out our keys. So in production, we have like a real key. But in like in a dev mode, we use like a fake key so that we can test stripe out and we can do all of our like unit and UI tests and stuff like that on it. Well, I only want to expose those so far, and really on the UI, I don't actually want to know about the key. Like when I'm building a UI, I don't want to know all that. That's like minutia that's already been built. I don't care about that. What I want to do is say like, you know, make a payment to Google Play, or Google Pay, or make a payment to Apple Pay, and it does it. And so what we're able to do is like hide all of the stuff that we don't care about deep in these layers and where it makes sense. What's that? Yeah. Oh, there's there another group. All right. So we're able to like hide our data back and keep them behind these other classes. So the repositories, often what they'll do is they'll make calls to these providers to fetch sources of data. They'll transform that data into something that the UI can then use. A lot of the time we're going to get back like way more information than we need, or we need to pull it from different sources, take that data, mush it into something that makes sense for our front end, and then display it. It's pretty rare that you have like a back end team that's like mobile specific, and they're going to provide you exactly what you need, how you need it, when you need it. Usually you're going to have to pull data from lots of places, transform that, aggregate that data, and plumb it into your UI. It prepares the information and the data for the next thing that we'll talk about, which are blocks. But you may do like sequence of requests. So in some places we'll have to do like 2 or 3 different requests to be able to get the data necessary for the UI that we want to display to our users. And so like a dashboard might be a great example. You're going to show a dashboard of different things to a user. That data may come from various sources. And so we have the ability to do that through these repositories. The only thing that can talk to providers, again, are the repositories. So we're kind of keeping that chain of like encapsulation. I think this one can go big. All right, blocks. Okay, if you're not totally lost, like blocks are like the coolest thing in the world. What they do is, like, if you're going to build like a Flutter app, just a normal Flutter app, you can do it without any of the stuff that I've talked about. Flutter provides state management inside of the thing that you build with. The building block in Flutter is called a widget. You can manage your state inside those widgets just fine. Like, it works really good. It doesn't scale very well. Like when you get multiple people in there, or like you take a 3-month vacation to Hawaii and come back, you're not going to know what's going on. But like, it works. And the first several apps that I built, that's how I did it. I just did it the traditional way. I can go and use widgets, and I can store state and everything like that. But as I started to build my app and it started to add more features and get more complex, I was like, oh, I'm in a panic. I don't remember how to do any of this. This is like way complicated. I have no idea. There's a lot of business logic here. And it's all mixed in with my UI. And so it becomes like this just massive pain in the butt to go and fix your code, and so you don't want to do it, and then, you know, whatever. So how do you separate that out? How do you get your business logic out of your UI and keep your UI really clean and pure and really easy to follow? Because in Flutter, your UIs can get really big. Everything is composable in Flutter, and so your UIs end up being like this big chain of widgets. And it's great, like, once you get used to it, and the tooling behind it makes it really easy. But if you have your state mixed in with that, it becomes really difficult to manage. And as you get complex UIs, it's a beast. So blocks allow us to pull that out and separate our state and what our app should look like. And like a state might be like a checkbox. Is it checked or not? That's just a piece of state, right? We usually track that through a Boolean. So that Boolean, we pull that out of our UI, we put it in the block, and then when our Boolean is, like our checkbox is checked and unchecked, all it's doing is, let's jump over here. All it's doing is, like, the widget, when we check the checkbox, is sending an event to our block to say, hey, I was checked. The block then can do its function. It can be a black box. It can take its input and says, hey, like, they checked this box. What should I do? maybe your application when you check that box, it needs to save that into like some local storage. Maybe it needs to do like a flipping API call, which would be crazy. And it goes and does an API call, and it has to return back some value, and then that's how you update your checkbox. Like there could be all sorts of business logic around just a simple checkbox being checked. How do we get that out of our UI? And this is how we do it, through these blocks. So a widget, the checkbox gets checked, sends an event, and then we process that event in the block, and then the block sends state back to our UI, and we can update our UI. And it ends up being really clean. Do you have a question? Yeah, it might be a little hard because they're usually pretty related to one another. So it depends on how generic your widgets would be. But you can use a block, like you can have like many blocks inside of one page, for example. So since widgets, like everything is in Flutter is a widget, everything. Your entire app is surrounded by one widget. And so what happens is like you can have a widget and a block tied together, and that's totally cool. You can reuse that anywhere you want inside of your application, and they're kind of a plug and play, right? You can just plug it in anywhere you want. Oh, I'm sorry. I meant to say that. It stands for business logic component. There's 3 words, but there's 4 on here, so whatever. Sounds nice, block. Business logic component. So its goal, again, is to just separate your business logic and your state out of your actual UI and what it looks like. So in the sample app that's out there, feel free to dive in. It's got a block example, and then it's got like the UI for that. I didn't even tell you what the app does. Did I show you a picture? That image on the side there, that's just like loading up 30 images from Pixabay. You just have to go get an API key, plug it into the API service, and it'll work just like this. Then you flip the switch up there, and it'll turn dark mode on, and all it does is change the action bar at the top there. But to do this, so web support's like off a few months still, but so yeah, the app that I built is built and is designed specifically for Android and iOS. So either of those phones, you can install Flutter, set it up, just pull down, do a git pull, and get the repo, and then you can just run it. Open the app up in whatever ID you use, and run the app, and it will install on your device, and you'll be able to have it. I mean, it doesn't do anything terribly special. Inspecting the code is probably way more interesting because this is what it will look like, except there's 30 of the images, but that's it. The question was, does Android Studio support Flutter? Yeah. So the IDs that are supported out of the box are VS Code, Android Studio, and IntelliJ. Unless I'm missing one, but I think that's it. So any of those, Android Studio is free. It works really well with this. You can deploy from Android Studio. You can deploy to iOS devices and Android devices. So it's not like specific to one or the other. Both of them. You can also do everything with Flutter from the command line if you wanted to, like run it on a device or whatever. Whenever I deploy to release, I'll do that from the command line. So back to blocks. We have our widgets, and we have like this this thing that's going to hold our state and keep it separated out of our UI. When I check that checkbox, it sends an event saying to the block, "Hey, I was checked," and then the block can make its decisions on what should happen. Maybe that checkbox is disabled, or we don't want it to be checked until they. How about this is maybe a better example? Like a login button is disabled until they accept your terms and conditions. And so when they check that checkbox to check your terms and conditions, that sends an event over to your block, and your block can say, okay, they checked the terms and conditions. Let's do this. Let's update our state. Let's say the login is this, or the login button is now enabled, and that checkbox is checked. Great. We'll update our booleans inside of our block, and then we'll just notify the UI that, hey, I've updated, and then the UI can respond accordingly. So it allows us to have that really clean separation of state and events. This has a learning curve. Don't get me wrong. When I started out here at NAV, we actually use something called Scope Model, which is great. It has a smaller learning curve. It's not as aware of life cycles of widgets, and so as you grow and scale, I found that that doesn't scale very well with the team and with the complexity of apps. So that's a great intro, though, if you want to like scope model is what it's called on that GitHub link. There's a link to scope model in there as well. But when you want to get serious about building applications that are scalable and that can build with large teams, definitely you want to go with Block. So kind of to clear things up, and I hope there's questions because I feel like I went really fast through like some heavy concepts. The goal of like our architecture was to have single responsibility principles to be able to be reusable and maintainable. And this really does allow us to do that in, I think, the best way possible, at least the best way that I know of. It allows us to test all of these different layers, to mock out everything that we need to mock out, to have our business logic separated from our UI, so our UIs can be changed really easily without having to do like a ton of work and figuring out if I remove this thing, like what breaks and how do I need to fix it. Instead, I just can remove the thing, and then it works. It's pretty brilliant. So, what questions do you have? Do you have any questions about Flutter? I just assume people knew about Flutter, but maybe not. Yeah. So the question is, does Flutter come with a Material UI kit? Yeah, it comes with one called Material and another one called Cupertino. Cupertino is geared a little bit more towards people that are iOS kind of friendly. Fun fact, I was on a call with like some people from Google that work on material design, and they're doing some research right now to see, does it really matter if they have a Cupertino or a material set? Can they find some, like, do people really care if your app is pixel perfect iOS or pixel perfect Android? Do people, like, they actually don't know that for a fact. There's a lot of assumptions that you can write a generic UI and people will just fine with it. Devs might not be, but everyone else in the world probably will be. So they're doing some research to really nail that down and figure out, like, what are people, does it really make a difference if we have, you know, our iOS bottom bar has got icons that are slightly smaller than the material ones, and it'll be really interesting to see the results of that. Yes, there's tons of dependencies. In the sample app, there's a file called a pub/spec YAML. That is like your file where you declare your dependencies. And there are several dependencies that are pulled in, and kind of like traditional Android development and React, well, anything, right? Dependencies are how you get things done. People building open source software and you using that, it makes all of our lives much easier. So, yay, open source. Yeah, very popular dependency, like hugely popular, highly respected developer. There's one called Block and Flutter Block. So Block is agnostic to, it doesn't have anything to do with Flutter, it's pure Dart. The Flutter Block is more specific to Flutter.
I have two quick questions.
Yeah.
So the first one is, if you were to hire somebody for your team, for your Flutter team, what would you look for in a candidate? What are some of the things or characteristics that you look for in a candidate?
Hard question to answer without some constraints, like how much money do I have to pay them, and things like that. Am I hiring a senior or junior? But if I were hiring a senior developer, there's a couple of things that I look for. Are the ambition? Do they work on projects on the side? I've hired many people over the years for different companies, and often I find people that do stuff on the side tend to bring a better skill set to work, and then they learn things on their own, and they bring things to work. The caveat to that is that they've got to be able to compartmentalize those things and not bring their personal projects to work. They've got to be able to focus, like, be here when you're here. So that's a key thing. Like, people that aren't asses, like nice people, you know.
Yeah.
People that are fun. I like to play foosball, so if they like to play foosball, that's even better, you know.
Yeah, so Flutter is fairly new, so I was wondering, there's not many people that know Flutter and Dart, so
Yeah.
if you were to hire somebody, I know Flutter and Dart is really similar to JavaScript, and as long as you're learning quickly, as long as you're agile and versatile, I guess anybody can learn Dart and Flutter, right? So
Yeah,
when it
so
comes to
so an
technology,
interesting, maybe this will help give some color to this. So the story here at Nav, we had an iOS and an Android app. I was brought on, and we just took a step back and evaluated what are we offering, and how are we offering it, and we want to go much quicker than we're able to. There's some constraints that we couldn't grow the team right now, and so how do we go significantly quicker? With the team that we have. And long story short, like we went on an offsite. I went with the iOS guys, and we just talked about Flutter, and we built some stuff, and we kind of went through the rigmarole of learning it. And after the week, we came back, and everybody was fully bought in. The iOS guys love it. They think it's great. They're totally sold on it. One of them is even that was the most hesitant, has gone and since published a personal app on the side. And he built it in a week, and it's got a bunch of users already, and good for him, you know. So if I'm looking for like the skill set, like who's going to fit into a Flutter world, Android or iOS, I don't think it necessarily matters. The interest needs to be there, and ideally, they need to have done something on the side. I really would like to see that ambition and see somebody who's gone and set up Flutter on their machine, can have an intelligent conversation about it. They don't need to know everything. Like I don't know everything. I don't know why, you know, I would never expect that, but they need to have like a basic understanding of what's going on. If they understand Flutter, then they would never ever compare it to React Native. Like that's a dead giveaway that maybe they just really fundamentally misunderstand what Flutter is. It's nothing like it. It's like they're completely different technologies. Like at the very core, they're nothing alike one another. And so if somebody were to come in and say, but I've done React Native, usually it's just like, well, you're not educated enough in it. And that's not necessarily a showstopper, but if they're going to, like, a lot of people, that's the reason why they won't get into it is because they've been burned in the past by other technologies. That's great input, yeah. I mean, Dart was originally built to replace JavaScript. It failed horribly, but it is. It is. It's not a bad language. And so it does have a lot of the same kind of concepts, but syntactically, I think it's way more like Java. I think it's almost identical to Java in so many ways, which is a little annoying if you've gotten used to Kotlin, because you have to go back to the semicolons and a bunch of other stuff that maybe you're not used to. But once you get into the language, it's really not a bad language. It's got some really nice things to it. They're building the language out. So if the language is a showstopper, which I've heard some Android devs like, I don't want to do Flutter because I love Kotlin so much. That's fine, but I've done Android for 12 years, and I'll never write another Android app if I don't have to. This is beautiful. This is like the most wonderful. I can go so much faster in Flutter. I can build things at a pace that I never could in Android land. Like not even close. And I get iOS for free out of the box, so it's pretty incredible. It's a good story to tell. Yeah, there's thousands of plugins already available. Yeah, and the majority of them do. And this is a good question because in React Native, there's thousands of plugins available too, and most of them don't work on both platforms. Yeah. So a couple of things that you get out of here is that Google has a team assigned to support many plugins, a few dozen that are really core, like geolocation. I mean, there's a whole bunch. Path Provider, which allows you to grab. So I could say like, give me the temporary directory, and the team at Google has already done the work and maintains that work to be able to figure out where is that temporary directory on Android and iOS. And if you're familiar with Android file systems, they've changed it like a dozen times. And so it's like there's like this complex nightmare that they've already dealt with, and they're willing to maintain and manage that. So there's people paid by Google to manage and maintain those things. So far, there's a couple of things like the fingerprint authorization stuff. We use that here at Nav. There is a bug with it when you have a phone that has like an on-screen fingerprint reader. So you'll run into issues like that, and you've got to work around and figure out how to make that work. Generally speaking, I think that's probably the only one we ran into here at Nav. Most of the time, those plugins are well supported and pretty good. I have that concern. Like that's a deep like looming thing. But generally speaking, because we've got the backing of a company that actually pays people to help support that software, and I think we're pretty good, far better than Facebook. I'm gonna jump over there and I'll come back. GitLab, and this is really cool. We can build our iOS and Android apps, run our lints, run our unit and widget tests, all in under 5 minutes, which is pretty incredible. When I worked at doing React Native last year, it was well over an hour. So pretty awesome. Yeah, GitLab has like a CI pipeline built into it. I really like GitLab. This is the first place I've ever worked with GitLab, and I'm like, this is so cool. Way better than GitHub. It's different. Like it is when you get in there and the learning curve. It's not a huge learning curve. It's pretty reasonable, believe it or not. I think React Native has a bigger learning curve, which is weird. When you get in there, like it's going to look different. It's going to feel different. It's composable. Like everything is super composable, and that's not like traditional Android or iOS. Like it's very different to use objects in this way, and given that, it ends up being really nice in the end. But there's that first learning curve part. When you say, is it flexible, what do you mean? Yeah. So widgets are infinitely like customizable, however you want. Yeah, like you everything's a widget. So like a checkbox is a widget. Like the whole background of your app is a widget. The app bar at the top is a widget. And those widgets have widgets inside of them. So we're talking like a big nested tree. And that tree has some really complex algorithms that let them do like diffing and there's really some magical things. So when you do a hot reload, they're able to inject your code, and the hot reload is sub 100 milliseconds, and you're able to see your UI. So I can go most of the day, and I can refresh my UI all day long. Where in Android, maybe it takes me 30 seconds to build my UI. So if a designer has like a spec for me to build to, what happens is like on Android, I'm going to build that like maybe 3 or 4 times, and I'm just going to call it good and hope they don't notice. Because like that's like 4 minutes of my time, right? I've got other stuff to do. Where in Flutter, I can tweak that thing for 4 minutes, and I've done it like 4,000 times. Like I can just over and over and over again. You can refresh your UI and update it really quickly. Yeah, I think that's it. Yeah.
So at Allo, we have iOS and Android, and we'd love to have a web app.
Uh-huh.
What are your thoughts on the web app that they just released? Have you ever done it before? Are you planning to expand to the web app?
Yeah, so currently the state of the web app is that they're forked. So there's Flutter for Android and iOS, and there's Flutter for web. They're different packages, so they're not compatible yet. What they're doing actively right now is merging that code back into the Flutter repo. They did that for a whole bunch of technical reasons, but once it's merged back in, I think we have the coolest thing. Like you're going to be able to build for Android, iOS, and Flutter. You're going to be careful. Like the Dio library that I talked about that we use, I don't think it's compatible with the web yet. So that you want to like make good choices about like which technologies, if that's your plan. But imagine a world where you can build most of your UI once, and it works across all platforms. It's just crazy, and it will actually work. And I guess we didn't really cover this. Like the fundamental like basic difference between Flutter and everything else is that Flutter owns the entire screen, pixel to pixel, edge to edge. So it's more like a gaming engine than anything. That's essentially what it is. You build an app in Unity. All it's going to do is going to grab a view, and it's going to draw on that view. And that's essentially what Flutter is doing. It's drawing on the entire screen. It owns every pixel. So you're able to like color those things and make them pretty and do all the things you need to do there. Fundamentally different than bridging over to native views and having like conflicts between Android and iOS. I think that's only partially true. Okay. I think their plan is to be able to export almost everything they can into JavaScript and CSS, and the things they can't draw will draw on a canvas, which then you'll run into SEO issues. So, yeah. Okay. That's good to know. Since Dart is a web language by nature, they're able to do that pretty magically. The thing that draws on the screen is called Skia. It's the thing that Android has used to draw for a long, long, long time. So it's really well defined. And when I started this, I have a foosball app. I had like this cool thing I wanted to draw. And I was like, I don't know how to do this. I knew how to do it in Android, so I went and did it in Android. I was able to copy the Java that I'd written it with. I dumped it into my Dart file. I cleaned it up a little bit, and it worked because the Skia between Android and iOS, or the way you paint, is the same between, not the same, but it's really, really similar between the two. So I was able to just take my code, dump it in. I had to update a couple of things, and it just worked. It was like, this is great. Like, I can take all my Android knowledge with me and build and draw and do custom things. Any other Flutter questions? Yeah. Uh-huh. There's a tool for that, so I would just use the tool, and then it'll differentiate between where to pull the data from. Most of the stuff that you're going to need to differentiate on the UI is going to be in your widgets, and so you can go and just do a check and say, like, are we an iOS app or an Android app or web app or whatever, or what are we running on, and then make your decision based on that. And often we'll do that in the UI because those are decisions that that are very UI specific. So I wouldn't pass that over the block and make a decision and come back. I think that's a little too heavy. Yeah. So the concept of a widget in Flutter, this might answer your question. I hope it does. Is it's a tool that has 3 lifecycle events. It has, well, generally 3 that you need to care about. An initial state, like initialize, a build, and a dispose. There's a few other things that you can listen to and care about, but generally those are the 3 things that you need to worry about. What will happen is that maybe I call my widget like my widget, and so I take my widget and I build a UI inside of the build method, and then I'll accept a certain piece of data into it. Maybe it's a piece of text, and so I'll take that text in, and I'll in my build method, I'll like show that text and maybe do an animation or something like that. That is now like a reusable component. I can take that thing and I can plug it in anywhere I want and reuse it, and it's ready to go. So there's like two different kinds of widgets: stateless and stateful. Stateless is going to be one that like it is just like I described, where I'm going to take the data in, I'm going to display it. I'm not going to do any kind of logic. I don't need to worry about state. Just whatever you give me, I'll deal with it. Where stateful, usually on stateful widgets, I'll apply a block to it so that I can separate that state out and have my UI. If it gets complex, definitely we would do that. And then I've got a tool to be able to do that. And again, those 2 are just reusable again. All I have to take is that widget and plug it in anywhere. It knows about my block, and I don't have to worry about that anymore. And web and Mac and Linux and Windows. Uh-huh. So if you go to pub.dev, you'll find Flutter Web and all. Inside of here, you'll find Angular packages as well that are built in Dart that you can use. And so for Dart itself, you can use pure Dart things into Angular world if you wanted to. The Flutter for web is going to be very different than the Angular. They're not even related. Flutter for web will be I build a Flutter project and I export that, and they're going to do a whole bunch of magic that will take my code, it will convert it into JavaScript and HTML, and draw on the web, like draw on a canvas, the things it can't, and that's my thing. So it's a very, if you look at a traditional Flutter app now, that's basically what you'll export when you have a web app. You'll get a folder with your HTTP, your index file and stuff inside of it. Upload that to your server, and you've got your website. So not really Angular specific or related to the Flutter app. It's you build with Flutter, and that's it. You're done, which is kind of cool. I can build once, and I can reuse that just about everywhere. This is really, in my opinion, a game changer. You'll be able to reuse components across all platforms. There's really no limitation. You can even use it on a Raspberry Pi, which is crazy. Yeah. Any other questions? Yeah. You can. Yeah. Yeah. There's some great tools that allow you to do background processing on Android and iOS as a background service. They're pretty new. They just came out. Well, I don't know that they're pretty new. They've been publicized recently, so I've seen them. But yeah, you can do. I haven't ran into anything that I'm limited to do yet. I have some pretty heavy Android apps that are very Android specific. So if you're doing like audio management on Android, that can be a little hairy. I don't think there's any library for that. It's not a cross-platform thing. The things you could do with audio in Android, you can't do in iOS with managing like your volumes and stuff. So there are some like things you might want to avoid. So this is a good principle to live by. Just like do a little bit of research first before you go all in on it. But I'm really not concerned about the ability to support both platforms long term, which I normally would be. I mean, my year of React Native really taught me some lessons. So, any other questions? Yeah. Yeah. So Dart is Google's baby. Created a long time ago. It's a pretty well-established language. It's very stable. So I don't know the story behind Dart. Unfortunately, you're free to Google it, though. I'm sure there's like some great information. But some geniuses at Google decided that they wanted to try and see if they could build. I think originally they wanted to build Flutter to run at 120 frames per second. I think they ended up at 60, which is still like amazing. So it runs at 60 frames a second now, but I think their goal was a little more ambitious back then. I think Flutter started 6 or 7 years ago. Correct me if I'm wrong. So they began the project, and they started on it. I remember looking at it like maybe 2 years in. And I'm like, oh, see, I didn't think it'd ever turn out to be anything. But they just steamed ahead, and they came out with some really clever solutions. And I think what they've had the opportunity to do, that you might think they're late to the game, and in a way they are. But what they've had an opportunity to do is to look at other people's failures and learn from them and make much better choices and decisions. Yep, supports back to 14, so you can go all the way back, and you can have a really nice experience on like devices that are just dirt old, and you'll get like tools and you can provide a UI to those really old devices that they don't get any other way with updated material design specs. So it's pretty compelling. No, Dart, the magic behind Dart is it can do ahead of time compilation and just in time compilation. And I'm not a compile guy, but what that does is it allows it to do this Flutter thing. And I don't know if there's another language that can do it. So when you say like, well, I have to use Flutter with Dart, they're a package deal, and so as long as Google is investing in Dart, you can be assured that they're going to be investing in Flutter and vice versa. this is the reason why we get like sub-second like reload times, and we get like a great set of tools. When you build the app, you get great inspection into your apps. Your error messaging, unlike React Native, you get like really good error messaging most of the time. Like, and they're working on that actively and improving that very consistently. They have updates that come out about quarterly, and then hot fixes that come out in between there. They have 3 different channels you can use. You can do stable, master, or dev. So you can actually, like, if you want to see and try out the code as it's merged in, feel free if you dare. It's pretty cool. Yeah, that is. Yeah. The question is, how do they manage the touch? I think there's like probably like a team of people behind that, and I don't have the answer for you. I mean, what they're drawing on though, like essentially, is that you'll take like in Android an activity, and you'll in iOS you can take a view controller, and inside of those is a view, and what they're going to do is they're going to draw on that. That view takes up the whole screen, and all they're really doing is drawing on that view, and so that view can interpret hits and touches. I don't actually know if they're using like the native views to interpret those things, or if they have a layer that they use to do it. I'm not exactly sure how it happens, but it works. It works really well, and they, I mean, you'll get a great experience out of it. Yeah, so they have all the tooling for keyboards, for other types of input that you might have. Yeah, it's all baked in. Really, like, you've got all of the tools to build apps, accessibility, everything you need to build like enterprise level applications that you need to support a variety of folks. It's really an impressive set of tools. I know the guys at Instructure are friends, and they like, that's where I used to work, and they build apps that have millions and millions of users, and they're considering Flutter for future projects. They're doing a spike, I think, next week on it. And like, enterprise level people totally good with it, and they have to support accessibility and a bunch of other like really difficult things, and it all works. It's really good. Back to you. Oh yeah, you'll get customized physics based on devices. Yeah, you're not limited by Flutter. You can reach out into the native code and do whatever you need to do. So if you needed to do, like, we do some specific stuff with Google Pay that I mentioned earlier. And in order to do that, we needed to reach into the native code to do that. So they have in React Native, it's called bridging. In Flutter, it's called platform channels. And they're really similar concepts. And so you can reach out into the native code. It's super fast. I think they just send strings over it. And you can reach in, you can do whatever you need to do, async await, and get your response back. You can listen to stream of events. So if I have something in the native code that I need to listen to, like a stream of events that I can't do in Flutter for some reason, you can just totally listen to those and register to listen and unregister in your code. So if like, here's the caveat: if you're having to reach into your native code a lot, you probably shouldn't be building with anything that's cross-platform. You're probably using tools that that are meant to be native, or you need to build the tooling, and if you have the resources and the capability to do that, that would be great. But if you're doing that like 50% of the time, like, it's totally, like, I mean, you just kind of zeroed out the benefits. Totally, yeah. You'll be able to arguably offer more features with Flutter because you're not tied to versions of the platform. You're able to, unless they're like very platform specific, but you're able to provide a user experience that is going to be next level beyond like anything you could provide. I do think you get, yeah, I'm totally sold. Like, this is it. This is my full-time job for a reason. There was one more thing I was going to tell you, but any other questions? I hope that helped. I hope, you go and experiment with Flutter. There's people looking for good talent, so go dive in. It's well worth your time. Like like I really do think that you have if you choose to do this right now, you have a bright future. There's I don't think a ton of jobs out there right now, but there are some. Get going and learn what you can. I managed to weasel my way into a Flutter job, so I'm sure you can too. Thanks. Feel free to check out the GitHub repo. Do whatever you want with it, but it does provide a pretty good sample of. Like for me, I would take that app. I would just dump the code into a new project, and that's how I would start building my app every time. Yep. Yeah, exactly. Yeah, I mean, it only does. What it does is like the architecture. We'll say like okay, build their application. How do we slice that up? Their application as small as possible, especially for like the market or whatever. We need to have this kind of like search marketing and all of that. Or yeah, and so like the app offer, you only have to upload one file. You upload that one file to Google, and then it will slice it up. Maybe I don't know. I'm not exactly sure. My goalkeeper app, when I slice it up, it ends up being about pretty good size, yeah. And it's a yeah, it's got
Talk about the same.
without those. I was waiting for you guys to do a platform on iOS. So
A quick question for you. How much of this is residing on the device and how much of it is on your server? So, like, like progressive web apps. I mean, a lot of the JavaScript is on the device, but that means that someone can basically look at the business logic and everything like that.
100% of it's okay.
So it's compiled in C. Binary. Okay. So that's the security.
Yeah, there is a way to obfuscate your dark code, but I don't actually think that's obfuscation for it.
Yeah.
I don't actually think the obfuscation is actually dark. I think that's right. Full priority.
Yeah.
So when you actually get these for a
Yeah. Well, what I was thinking is like when you were showing how there's the API and the providers and the repositories and everything.
what about
What- Yeah, and it compartmentalizes everything so you know what piece talks to what and where it belongs.
centers are like security, our environment, so they're all
Right.
and so we only have to expose those.
Yeah, so what I was thinking is building all that, the class information in the API. So then basically the progressive web app that I was working on, mobile app, would simply have a business logic user interface and it would talk to the API. So that essentially anything from the block level out would be on the device and everything else would be behind an API. That's how I was thinking. Well, that's the reason I like Dart. I was looking at Flutter and I'm like, okay, this is cool. So I was excited about this tonight. Yeah. Yeah, and it's so comprehensive too. The only thing that I didn't like about it, brought it up tonight, is I wanted my app to be as useful on a mobile device or tablet as it would be on the desktop. So I wanted to have browser-based, everything that you could do on smaller footprint would be available on larger footprint plus some.
That gets tricky because
It is. Yeah, Opera or Apple. So
the broader you go,